Hi everyone, welcome to this video. We are going to look at a problem that appeared some time ago in the CT4 exam of the IFoA, September 2009. I've indicated that here. Now, of course, it is part of the subject CS2. Okay, it involves the Cox model. And just to run through the question, right? A study was undertaken into the length of spells of unemployment among young people in a certain city. And a sample of young people was monitored from the time they started to claim unemployment benefit until they resumed work or they moved away from the city. None of the members of the sample died during the study. Okay, the study investigated the impact of age, sex, and educational qualifications on the hazard of returning to work using the following covariates. So let me tell you a few things. We are looking at age, we are looking at sex, and we are looking at educational qualifications, the hazard of returning to work, that's also important, and we're using the following covariates. A young person's age when he or she started claiming benefits. Again, a young person's age when he or she started claiming benefit, measured in exact years since his or her 16th birthday. Exact years since his or her 16th birthday. So I have labeled some values here for you. So if you're 16, then A will take a value of 0. If you're 17, then A will take a value of 1. 18, then A will take a value of 2, and so on. S, dummy variable, taking the value of 1 if the person is a male, and 0 if the person is female. I've also indicated that here. Male is 1 and female is 0. And then I have a dummy variable taking the value 1. This is E. Yeah? If the person had passed a school leaving exam in mathematics, and 0 otherwise. I've also indicated that here, kind of briefly. Pass is a 1 and a fail is a 0. Okay, great. You know the story. And we are looking at associated parameters B, beta A, beta S, and beta E. Okay, beta A, beta S, and beta E. So you know the story. Now, basically, when you should be aware of what we need to do roughly, right? Okay, the investigators decided to use a Cox hazards regression model for the study. I'm not going to talk about those things that you'll find in your readings. Let me just move the screen up a little bit, and then we will talk about that. Some things that you can find in your textbook, let's not go through it, right? You can easily look it up. Let me erase this. Okay, great. So we're going to use a Cox model for the study A, or rather part 1. We asked to explain what is meant by a proportional hazards model. You look this up. Explain why the Cox model is a popular model for the analysis of survival data. Also, you can look these up in the readings, right? The responses are pretty obvious in the readings. I just want to look at the calculation part of the problem. Part 3, they tell you to write down the equation of the model that was estimated, defining the terms you use, other than those defined above. So let me read that again, right? So you asked to write down the equation of the model that was estimated, defining the terms you use, okay? So I've written the response here, lambda tz, okay? Lambda tz, your hazard at time t, okay? This is your hazard at time t. And then we have our covariate vector, z, or z if you like. And then you have your baseline hazard, lambda naught t. And then we have our g of z, okay? A g of z, which is e to the power of a beta A times A plus beta S times S plus beta E times E. Yeah, I'm using the parameters given here, okay, multiplied by the covariates. Good. So this is your equation of the model, right? You asked to list the characteristics of the young person to whom the baseline hazard applies. Okay, to whom the baseline hazard applies. So you can use these things. I've written all these things to help us along. Okay. In my class, I tell them just plug in the value of z equals to 0. Well, here it's A, S, and E. So here I'll plug when 0, somebody's age 16. Okay, when you plug in 0, somebody's age 16. That's the first thing. And then when you plug in 0, somebody's female, and you plug in 0, he has failed the exam. So your baseline characteristic applies to who? Correct. Females. Okay. Females, exact age 16, and did not pass the exam or fail the exam. Okay. The math exam. So the next part of the question deals with some data they've given us. So let's just quickly breeze through it. I'll set it up for you, at least the first part, and then you can follow the second part and so on. And you need to probably solve, not probably, you have to solve a system of equations, okay, and you'll be done. So here we have it. Okay, good. The results showed, right? Let's read the first bullet point carefully. The other two bullet points you can follow along and set up the equations that you see. The hazard of receiving work for females, right? Okay, for females who started, let's see, the hazard of resuming work for males, sorry, who started claiming benefits. Let me erase this here. Okay. The hazard of resuming work for males who started claiming benefit, age 17. Okay, age 17, right? So we are looking at A equals to 1 now, right? Okay. Then 17 years exact, pass the exam. So we are looking at E equals to 1. And we're looking at males, so S equals to 1. Okay. So I plug these numbers in so that I can easily plug it into my hazard function. Okay. And what else? Was 1.5 times the hazard for males. Okay, so I have on this side, I have S equals to 1. I've written it here just in case you can't see it. Okay, S equals to 1. Who started claiming benefit age 16 years exact. So you know A will be 0. And then who had not passed the maths exam. Not passed the maths exam, so I have E equals to 0. So we use these values, right? We use these values. And remember, one is 1.5 times the other. So you can set this up. Okay? You can set this up. And you're done. Okay? And you're done. So let me just. Okay, this part here. Okay? So this is setting up the first equation, and then you can clean up the algebra here because I have E to the power of beta S here, and no, hang on. Yeah, E beta S, I can cancel this and this. So I'm left with E to the power of beta A, okay, cancel this, plus beta E equals to 1.5, okay, E to the power of beta A plus beta E equals to 1.5. And then you take logs, right? You take logs and you'll get beta A plus beta E will be equals to log of 1.5. I've done that here. You do it slowly. Use the same reasoning, use the right values of the covariates, and you can set up the second equation and the third equation. Not difficult to do. Plug in the right values for the covariates, just like I've done for you in the first bullet point. Do the same for the second and the third bullet points, and you'll get these two equations. And you have a system of equations that you can solve very easily. I've done it here for you, really. Okay. I've taken one minus the other, yeah. Equation 3 minus equation 2, I'll end up with this, right? And then I have plugged into equation number 1 and solve for values of beta A, beta E, and beta S. Not difficult to do, yeah. Just a matter of getting hold of your Cox proportional hazards model. Look, if you are looking at this, you can see, right? I didn't bother about your baseline hazard, right? Because it affects all our risks equally, or what our book says, right? It's you don't really have to worry about it when you perform calculations like this because it appears in the numerator and the denominator, so they get cancelled anyway. Okay, so I've just used our G of Z if you note what is written in our reading material. So 3 equations solved and you'll get your answers. Okay, thank you very much for watching. I will see you in the next video.